So today we're going to add on to what we learned on Monday, and we're going to learn how to do these mass calculations. So first of all, when we talk about mass, we're talking about grams. Okay. So that could be the first thing you write in your notes. So if you're not sure what your unit is for mass, you need to start thinking mass is grams. Okay. So if you have a question that asks, like, what is the mass of, we'll say, aluminum, okay, that's asking for how many grams of aluminum you have. And so when we do these mass calculations in stoichiometry, we can now calculate the mass of any reactant or product, or we can calculate the mass of like any other reactant or product if we know one of them. So then the next thing you need to write down is just this real generic formula. Okay, so you don't have to write like this middle part down, but get down this formula. Okay, so our real generic game plan is we're going to go from grams to moles to grams. Okay. And we'll do practice problems together. So once we do practice problems, that'll make more sense to you, but like this is your rough outline of what we're going to do. Okay, so go ahead and copy down the balanced equation at the top. So copy down N2 plus 3H2 yields 2NH3. So we're going to calculate the number of grams of ammonia produced by the reaction of 5.40 grams of hydrogen with an excess amount of nitrogen. So we're going to start this just how we started them yesterday. So we're just going to write down, what do we know? Okay, so what number is given to you? Okay, 5.40 and it's grams of hydrogen. So underneath hydrogen, I'm going to write that 5.40 grams. So I know that's what's given to me. And then what are you trying to solve for? Okay, grams of ammonia. So I'm going to put that question mark under ammonia. And then I'm going to put the unit. So I know we're trying to figure out the grams of ammonia. All right, so now we're going to make a game plan. So before we just like jump into the stoichiometry, we're going to make that game plan. So what number are you going to start with? Okay, and what's the unit for that number? Okay, so you're going to start with grams, and it's grams of hydrogen. And then can you just go from grams of hydrogen to grams of ammonia? Okay, what unit do you have to convert to? Okay. So then we're going to convert to moles of hydrogen. Then we can convert to moles of ammonia. And then finally, what unit does your answer have to be in? Okay, and then we can get to grams of ammonia. Okay. So on the previous slide, you wrote down this formula of grams to moles to grams. Do you see how we're following that, like grams to moles to grams? Okay, so that's like our rough outline of what we're going to do. So before you just try to jump into the dimensional analysis, make sure you think through the problem. Okay, so do a little like groundwork to set it up. Okay, so now that we have the game plan, now we'll do the dimensional analysis. And what number goes in the very first box? Okay, 5.40. Units are important, so you need to have grams and hydrogen. Okay, you're starting with 5.40 grams of hydrogen. So now I'm just going to follow the game plan. So we're starting with grams of hydrogen, and we have to get to moles of hydrogen. So what do you have to use to convert from grams to moles? Okay, molar mass. So where do you find molar mass? Okay, periodic table. What's the molar mass of hydrogen? Okay, and what's special about the formula? Two of them. So what do you have to do with that mass? Double it. Okay, so now what's the molar mass? Okay, so 2.02 grams of hydrogen. Why does that one have to go on the bottom? Okay, you have to cancel. So if grams of hydrogen are in the top, grams of hydrogen have to go on the bottom. So grams of hydrogen cancel. And that molar mass, it's always equivalent to 1 mole. Okay, so that's where that 1 comes from because it's molar mass. So now we're here in the game plan. We have to get from moles of hydrogen to moles of ammonia. What do you have to use to go from hydrogen to ammonia? Okay, everyone say it out loud. What do you have to use? Okay, mole to mole ratio. So you're just using the coefficients in the balanced equation. So if moles of hydrogen are on top, what has to go down here? Moles of hydrogen. And how many are there? 3. So for every 3 moles of hydrogen, how many moles of ammonia do you produce? 2. And you grab that 2 just from the balanced equation. So moles of hydrogen cancel. You're left with moles of ammonia, and then you have to get to grams of ammonia. So how do you convert from moles to grams? Okay, multiplied by molar mass. My watch is going to do the work for you. Okay, molar mass. So if moles of ammonia are in the top box, that means moles of ammonia have to go in the bottom. How do you find the molar mass of ammonia? Good. You have to add both the molar masses. So ammonia is NH3. I'm going to show my work in blue. What's the mass of nitrogen? Okay, 14.01. And how many hydrogens are there? 3. And what's the mass of hydrogen? Okay. So what's 14.01 plus 3.03? Good. Okay, so 17.04 grams of ammonia. Okay, so moles of ammonia cancel. The only thing left is grams of ammonia. Does that match what your answer needs to be in? Okay, so that's how you know that you're done. So now it's time to calculate. So to calculate, multiply the whole top row. Get an answer. So 5.40 times 2 times 17.04. You can even write it down. Okay, so like multiply the top row, get your answer, write it down. Then multiply the bottom row, get your answer, write it down, and then you'll divide them. Okay, what are we getting for an answer? 30.36? Yeah. Do we agree? Okay. Okay. Sig figs for stoichiometry should be relatively simple. Usually it's how much you start with is how much your answer will have. So how many are in 5.40? Okay, 3. Are any of the molar masses less than 3? No. So what are you going to round this to so you have 3 sig figs? Okay, so 30.4. And what's your unit? Okay, so grams of ammonia. Okay, so this time we're using the same reaction. Okay, so N2 plus 3H2 yields 2 NH3. And then this time, we're going to calculate how many grams of nitrogen are needed to produce the 30.6 grams of ammonia. So we're going to start by just listing what we know. So what number is given in this word problem? Okay, 30.6. And that's grams of ammonia. So I'm going to write the 30.6 underneath ammonia. And then what are we trying to solve for? Okay, so nitrogen is what we're looking for. So I'm going to put the question mark under nitrogen and the G for grams. Okay, so now let's make our game plan. So what unit are you starting with? Okay, so you have to start where your number is. Okay, so you're going to start with grams of ammonia. And then if you have to get from ammonia to nitrogen, what unit do you have to be in to do that? Moles. Okay. So we're going to go to moles of ammonia. All right, then what do you think the next unit is you can convert to? Okay, good. Moles of nitrogen. And then finally, what unit does your answer need to be in? Okay, so then finally we'll go from grams to nitrogen. Okay, are you with me so far? Okay, don't be afraid to take the time, bless you, to make that game plan. Okay, the game plan is really important. If you don't have like the plan in your head of what you're doing, is there a lot of hope for you to like magically get your numbers right in dimensional analysis? Probably not. So don't be afraid to take the time to do this. So then now that you have your plan, then you can do the dimensional analysis. Okay. So then what number are you going to start with? Okay, 30.6, the only number given. 30.6, make sure you get grams of ammonia in there. All right, and then you have to get to moles. So what do you use to convert between grams and moles? What do you use?
Molar mass.
Molar mass. Did we just calculate the molar mass of ammonia in the last problem? Okay, what is the molar mass of ammonia?
17.04.
Okay, so 17.04 grams of ammonia is equivalent to 1 mole. So now we're here in the game plan. So to get from moles of ammonia to moles of nitrogen. So from here to here. So what do you have to use? Okay, everyone tell me, what do you use to get from here to here? Okay, multiple ratio. If no number is written, what number is implied? Okay, 1. All right, so moles of ammonia is up here. So what has to go down here? Okay, and how many moles of ammonia? 2. Okay. All right, so then for every 2 moles of ammonia, you use up 1 mole of nitrogen. And then finally we have to get from moles of nitrogen to grams of nitrogen. So what do you use to go from moles to grams? Okay, molar mass. What's special about nitrogen's formula? Okay, it's diatomic. Do you see how it's N2? So what do you have to do to its molar mass? Okay, double it. So what's the molar mass of nitrogen? 28.02. Okay, so our moles of nitrogen cancel. The only unit that doesn't cancel is grams of nitrogen. Does that match what our final unit needs to be? Okay, so it's time to calculate. So everybody practice. Make sure you know how to type this in your calculator. So multiply the top row, get an answer. Multiply the bottom row, get an answer. Then divide up. Does anyone have an answer?
Yes, ma'am.
Okay, what are we getting?
25.16.
25.16. Do y'all agree?
Yes.
Okay. How many sig figs should be in that answer?
3.
Okay, so what are you rounding that to? 25.2 what?
Grams of nitrogen.
Okay, grams of nitrogen. Okay, new equation. So go ahead and copy down this new equation. So for this equation, we're going to figure out how many moles of CaC2 are needed to completely react with 49.0 grams of H2O. Okay, so we're going to start this one just like the other ones. What's the known given in this word problem? Okay, so I'm just going to copy that down. So 49.0 grams of water. And then what are you solving for? Okay. Okay, moles of CaC2. So I'm just going to put a question mark. And this time the unit's different than the first 2 problems, right? We just want moles. So that's why it's helpful to write that unit down so you don't go too far and take it to grams. All right, so then for this one, we're going to start with water and we're going to calculate how much CaC2 we need. Do we do anything with this side of the equation? Okay, nothing. So we're just focused over here. So I'm going to make the game plan first. So what unit are you going to start with? Okay, grams of. It has to be the one you have the number attached to. Okay, so since we know grams of water, you have to start with grams of water. And then what unit do you have to convert your grams to? Okay, so then we can go moles of water. And then where are you going to go after moles of water? Okay, moles of CaC2. And what unit does your final answer have to be in? Moles. Okay, so notice this one you just have to get to moles, so we're going to stop here. Okay, so now we can do the dimensional analysis. What number goes in your first box? Okay, 49.0 grams of water. How do you convert from grams to moles? Okay, molar mass. What's the molar mass of water?
18.2.
Okay, so water is 18.02 grams. And now, what do you use to get from moles of water to moles of calcium carbide? Okay, mole to mole ratio. How many moles of water do you use in that equation? 2. Okay, so for every 2 moles of water, how many moles of CaC2 do you use? 1. Okay, if no number is written, what number is implied? 1. Okay, so this 1 is coming from this coefficient. Okay, and this time, the answer just needs to be in moles. So once you get this set up, you're ready to calculate. Anybody have an answer?
5.4.
Okay, 5.43.
Well, yeah, she's gonna split into 6 anyways.
Do you all agree? Are we getting 5.43? No. What are we getting?
1.36.
Okay. 1.36?
36. Yeah.
Here, at least 2 of you. 1.36?
Yeah.
Okay. 1.36 what?
Grams.
Okay.
Moles of CaC.
This one, I'm going to help you get it started, and then I want you to finish it on your own, okay? So same reaction as the previous problem. This time we're looking at how many grams of C2H2 are produced by adding water to 5 grams of CaC2. Okay, so set it up right. So what number, is your given number that you're starting with? Okay, 5, and what's your unit? Okay, 5 grams. I like to write that under CaC2, so I know that's where I'm starting. What are you solving for? Okay, so we're looking for the C2H2, so I'm going to put the question mark there. And then what unit should your answer be in? Okay, grams. Okay. So, always take the time to get set up. So think about where are you starting, where are you ending. And then you can write that game plan. So what unit are you starting with? Okay, grams of CaC2. Then what unit are you converting to? Okay, then you're going to moles. CaC2, then where can you convert to next? Moles C2H2, and then finally, what unit does your answer need to be in? Okay, so now I want you to try the dimensional analysis part on your own, and then we'll check answers. Okay, let's go ahead and check your work. So, did we all start with 5 grams of calcium carbide? Okay, what do you have to use to get from grams to moles? Okay, what is the molar mass? 64.1? Okay, and then what do you use to get from moles of calcium carbide to moles of C2H2? Okay, multiple ratio, which is 1:1. And then finally, what do you use to get from moles of C2H2 to grams? Molar mass, which is 26.04. Okay, do y'all agree with the work and how it's set up? Okay, so what are you getting for a final answer?
2.03
Okay, 2.03. What's your unit?
grams of C2H2.
Grams of C2H2.